Okay, we have shot, we have picture, and looks like we have sound, maybe a little too much. We'll see. Welcome guys, again. Let's get back to the Milo CAD modification series. Sorry, my eye is burning. I'm a little tired today, as usual. So again, we are doing the modification, some mods on Milo CNC milling machine v1.5. So I disagree with some of the design choices. Some I can fix, some I can't. So let's do what we can. Yeah, let's get to it. So how is everyone doing today? It's not as cold as yesterday, so it's better. And yeah, I started a little earlier, just 5 minutes for warm-up. But yeah, let's do some stuff. So let me change to Fusion. Let's start opening stuff as soon as I find my mouse. Here he is. Always, yeah, it's good. It's good. Let me make sure. Yes, I'm live. Yeah, that's fine. Okay, so let's open my functional assembly. So yesterday we finished with the spindle, I believe. So I made these spindle clamps just quick and dirty. Probably I'm gonna do some tweaking on them later, but that's not really important. Yeah, okay, so today I think, okay, so this is how I set. So the spindle will be able to move quite a bit down. Usually we set it, let me, yeah, more like this. Usually we set it as low as possible, as long as we reach the table. Or what am I doing? Okay, let's look up to. Oh, okay. I pressed for a sketch. I don't want a sketch. So right now we are like 63 millimeters from the table, which is too much. Of course, we are missing the fixture plate in here, which is 10 millimeters more. And we are missing the actual mill, which should be at least, it doesn't matter. We should be able to reach the table, but we can always adjust that with just sliding the spindle down, so that's not an issue. And we are missing the vise on top of here, and whatever. So let's get to business. So what we need to do is actually, so I'm gonna I'm gonna open the Milo CAD, the fancy one, and we're gonna start with the ball screws maybe. Okay, so what I'm gonna do for reference is I'm gonna, well, maybe we should start with the front pieces. Okay, sure, why not? Let me check how are these. Okay, so these are supposed to be like that. So I'm gonna do a single piece for all of these. So I'm thinking so this is gonna be a very thick part because I wasn't counting with this step in here. Oh, it's 15. Okay, 15 it's fine. So it means we can use a 20mm plate. Yes, so that's what we're gonna do. So we can do that. So yes, we absolutely can do that. Let me check something. So I assume only a few. Okay, let me think a little bit. So let me take this out. I assume not all the what we have here in pieces. So okay, so we have a 4. We have a 4. Okay, so we have 3 4s. So 3 80/20s, right? And 2 40/20s. Okay. So I assume not all of the holes are threaded, but that's something we can do. So let's do a plate with about the same dimensions because I want the feet to be on the same position. So I'm gonna assume, and I'm gonna put screws on all of the holes, because why not? So yeah, let's do that. So let's make roughly the same shape. So let's start by measuring how long this is from here to here, roughly. So we have 342. And how tall are they? 70. So let's start with that. I'm gonna actually design. Yeah, I'm gonna do a separate design on this because it's easier than to do the machining and programming. So not everything is not everything is in the same place. I like to do that, and I'll just import. So let's do 343, and it's gonna be something like this on this shape. Shit. So here to here, it's gonna be perpendicular. That's already. Here to here, it's gonna be aligned. And we're gonna have here to here 70. And I don't know, maybe we're gonna call it here, maybe 10 millimeters. Should be enough. Here to here, we're gonna call it 135. Let's make it 45 degrees. So yeah, something like this. So about the holes, okay, let me do some. So we should have 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. No. So we are missing one in here, one in here. So it should be 12, right? I think so. Let me disappear with this screw. So V for visible or invisible. So let's put show snap points, otherwise we don't get the center points. Should be 110. No. 220. Yeah, 220 there. So 220 divided by 20, that's 11. So that's 12 holes. Fine. 12 holes. We don't have a center point hole. So this should be flat with the top, and it is. So let's do some shit. Let's do this perpendicular. Hey Joseph, how are you? Yeah, I'm fine, I'm fine. Little tired from work, but that's life. Okay, the good thing is we're gonna need 2 of these parts and they're gonna be equal, so just Just gonna be a copy paste job. Let's press X for construction type. D for dimension. We're gonna need it to be 10 millimeters here. And we're gonna need it to be 100 and not 110, 220. And it's gonna be centered. Point. Set. Messed up here. Yeah, there. That's what we want. So here it should be 40, I believe. Yeah, it should be 40. So let's put some holes on this thing. This should be N5, so we're gonna put it at 5.2. We have some clearance. Oh yeah, I'm gonna use my mill to make a mill. Start with oh, nice. So I guess you work on a locksmith store. Is it what it's called? Or a locksmith shop? Should be something like that, right? .2. Okay, we're gonna need some in here as well. Oops. Looks like I fucked up. Yeah, I'm gonna do that instead. So if I need to change the hole sizes by any chance, everything will be referenced to this guy. Come on. Come on, collaborate. Like that. Oh, that's nice. So you do like house callings and stuff. That's cool stuff. I like that. I actually like to do some. Okay, I see some problems already, but we'll figure it out. I like to do some lock picking myself, just to train myself with that kind of stuff. It's funny. I have some kits of tools that I bought, some I made myself. It's fun stuff. I really like to see that guy. Shit, I'm messing up. That guy from YouTube, the law picking. How is it called? Lockpicking lawyer, right? Yeah, the lockpicking lawyer. I really like to watch that guy. He's a master. It's fun stuff. So, okay, let me see what's the dimension called. So I don't call it all the time. D9. So if you... There's some ways to do this. Let's call a dimension here. So if I double click that dimension and I click this one, I get D9. So now if I do another circle, and on the size I write D9, it will get the dimension we want. Give me a second. Oh, I know that. I know those tools. Those tools are cool. And then you can make a key with the cuts. I think I'm gonna need to make a break to get my dog. Yeah, that's cool. Yeah, I saw them on a video from the lock picking guy. That's really fun stuff. I have no idea that those things existed. The guy read the... Oh, it was with a camera. I don't know if you saw the video. He had a camera that went into the lock, and he could read the thing with the camera, and then make a key, and yeah, and that's it. That's about it. With a fancy tool, with a camera, was nice. Yeah, something like that. Okay, so D9. Interesting stuff, lock picking stuff. D9. Okay, here I'm putting 20s, but it's 20. That ain't gonna change, so because it's the yeah, for the newer cars and even the many of locks, household locks, it's they need to be milled. It's not like it used to be with a serrated thingy. And yes, I could have used the pattern here, shit, D9, but well, why not? Oh, Flipper Zero. Flipper Zero, it's fun for the radio controlled gates and whatever. Actually, I don't own... Okay, let me increase this measure here a little bit. Yeah, that should be fine. Okay, so let's do... Yep. A friend of mine older guy. He installed a new gate on his warehouse, and I went there with a... I don't have a Flipper Zero, but I have an Arduino with a RF model on it, and I went there just to scare him a little bit, and I was like, "Oh, you have a new gate. Oh yeah, it's fun. You have a remote control for it. Oh, that's funny. So press the remote for open the gate." And I was reading the RFIDs with my little my little Arduino. So I recorded his code basically, and then okay, now let me try with my little thingy. And I had just a little program on it where it recorded, and then with two buttons, one for recording and the other one for replay the latest code recorded, and then the gate start opening, and he was like looking at me, huh? And I was like, yeah, very safe. Okay, looks like my dog is back, so I'm gonna close the door. Yeah, that one it was a simple one. Anyway, he has it as a second gate. So no, like it's the outside gate, but he has a mechanical one inside. So you always need a key to open it. It's just when he's around, so he doesn't have to scroll the gate all over. So he has that automatic one, but when he leaves, he has the second one that actually closes the thingy. Okay, so let's install the... Okay, let's call these the skirts. Skirt. And let's bring it to our design. I'm not gonna make the holes in here, doesn't really... Well, I'm gonna make one just to index the thingy. It's easier. So I'm gonna make it 5. Actually, let's make it real. 4.2. At 10. Just gonna make it easier to align the thingy. E for extrude. Let's make it all over. Well, we should have done... Okay, let me redo this. I should have done it on the base, so we don't mix the stuff. Here. 4.2. 10. And D from here to here. 10. Back to the other side. Yep. Okay, this way it's gonna be easier. I should have done it there, but never mind. So let's put in a skirt. Hey Kegel, how are you, my friend? Where is it? It's not. Okay, I'm gonna put it, yes, on the base. It's gonna be fine on the base. Okay, so let's do... Yeah, I should have done... Yep, Sleeper can do all that stuff. Come on. Oh, why is it anchored? I don't want it anchored. Shit. Should have done... Okay, let's do some changes. So let's redefine sketch plane to that one. And let's edit the sketch. So instead of in there, let's put it here. Come on. Yeah, like that. And yeah, that will work way better. So we can actually use this one to attach the thingy there. Join. Yeah, like that. Okay, so we need to either increase this length here, so we get these things to line, or decrease the angle. I really like the 45 degrees, so let's do it a little. Okay, let's do it. Okay, let's not put that measure, and let's put that measure instead. So that one should be to what? 240. Yeah, that should be fine. Yeah, especially if you, yeah, probably someone made a thingy where you do three times opening the thingy so it sees the pattern. So most likely it will do that. Okay, so let's save. So once we save, we can just update the model in here. There we go. Now we need to do some pockets in here in order to fit the those steps. So let's do that. Hopefully we're gonna eat on the right side. We'll see. So ideally we just want some 2040. We're gonna need to make them bigger, or at least do some ears for the, but we're gonna do it bigger. We're gonna do it like 21, just to make sure that 21 and 41 to make sure they fit. We're gonna align the centers with this one. And now we can do, this is the lazy way. So I'm gonna do a line there, So I can put a point in the middle. I should have, and put another point in here. I can just align this. This way, if I change the measurements on of the pocket, we always gonna be centered with those two holes. So let's do the same thing over here. So we're gonna call the length, the width, the same width as this one, at that one. We don't need that because we're gonna align. You see a lot of flies here today. And we're gonna align these two lines as well. I'm gonna create another point here so we can align these two. And that's about it. If we do any changes on that side, let's see, we increase to 45. That one will increase as well. If we increase this one to 22, this one will increase as well. So we are set. Let's do 41 for now. And for now, we are not making anything pretty. We can do that later. For now, we just gonna make it functional. So I'm gonna put minus 18.1. And let's save. It should be fine. Probably we're gonna use even a thicker. We'll see. We might like to see the screws protruding, but if you wanna do some counter bores, we can do on these ones, but these ones, it's gonna be too shallow because we only have like 5. Okay, I messed up. It's not 18.1. I don't know where I got the 18 from. It's 15. On this one, we only have 5 mils. And not even that. And pretty sure an M4, an M5 screw, a button head. What's the height of? Let's grab a screw here. What's the height of the thingy? 275, so it's 3 millimeters. Well, we can do we'll see. We'll see. Probably we're gonna do a 25 millimeters thick in here. Not 25, like 23. So I can use a 25 and then deck the top off. We'll see. For now, that's fine. So let's save it. Well, actually we can do that. Let's do 23. And now we have 7 millimeters, 8 millimeters. So yeah, we should be fine now for decking, for do some counter bores to wide the screw heads. We can do some kind of designs in here, but that's for later, not for now. Of course. I was expecting something like that, so let's delete the... Yeah, because I picked the wrong side. Doesn't matter. Okay, so let's rotate this thingy. 180. And then let's lock it into place. J for join. how far I am? Well, I need to finish all the modifications first that I want to do. Then I need to order the materials, and then I can start cutting. Okay, let me just do some sanity checks here to make sure I haven't done any stupidity. Okay, that's fine. That should be a little gap there. That's fine. Okay, looks good. And let's do the other analysis. Inspect section from this side. Yeah, everything lines up. No, the goal it's better built, proper built Milo, and here there's no issue with using, to be honest, there's no issue to be using the printed parts. But I have a mill, I can mill this stuff, so why not, since I'm spending the time building this machine, why not making it properly? So yeah, that's the goal anyway. And maybe make a kit, an available kit of my version of the machined parts, if someone is interested. But this part in here, to be honest, it's not the most important. To actually, we could lower this distance here a little bit. Well, that's something we can fine-tune later. At least 5 millimeters. There's no point of, or even the total. Well, at least 5 millimeters. We'll see. These parts, let's see. If you want to do them on a single, no, not exactly. On a single piece, you couldn't do that on the Milo because the Milo only have 340 travel on X. That's I think it's the absolute maximum. Well, it's not. We are not there yet. Maybe we can shave a little bit more of travel, but at this stage I can't say yet. But you could modify it a little bit, because if it's something like 334, 333, so 1 centimeter less, you could machine them on the Milo, or you could do it in 2 parts if you want. The only thing, I haven't even checked, let's see. So yeah, you could easily, since this is aluminum, you could easily shave a little more from here. Actually, quite a little more. Jesus, how many? Whatever. I'm not even commenting on that one. So let's check. What's the easiest way? Yeah, I'm pretty sure you can shave 5 millimeters out of this thingy here and finish it like something like there, and you can actually thread in the feet. There's no need to do the screw thing in here. You could just thread in the aluminum there and use a piece of M5 all thread or a long groove screw, a long set screw, and attach the feet directly to the thingy. So yeah, that one could be made on a Milo. It's stretching, but it's doable. Hey, Leash. So I'm not bothering because I have more than enough travel to make these parts. And they don't need to be very precise either, because they are not that important, to be honest. Especially if this whole thing is filled with epoxy. You just need to make sure that the filling, it's not protruding here. Otherwise, you'll need to make a pocket in here to allow the filling to. If that's the case, ideally, you would fill it with epoxy already with the plates there, and by that it's going to be fused, pretty much fused to the filling. But that's not really important. It's better, but it's not really important. Okay, so let's put the holes for the feet, and let's leave it like that for now. Then we make it beauty. Okay, so let's do some 4.2s. So I want to keep the feet in the same position, if I can. So in the same reference. So how the hell will I? Okay, so let me remove this thingy and this thingy, so I can inspect from center to center. So we have 320. So we have 343. So what we can do, some mat here. So this one, it's gonna be this one minus this one, close parentheses, divided by 2, and that should make it centered. So that's another trick. You can do math on the dimensions. Now let me check. Okay, let me disappear with this thingy. That didn't help. Okay, actually it helps. Yes, because I want to check against that surface there. So if I do an inspect, and here, and let's compare it to, let's say, this point. Oh, fucked up somewhere. Okay, so inspect that point to that point over there. Now if I press here the global coordinates, I'll get these components from the vector. So we are 10 millimeters off. So that means it's 10 millimeters from this wall in here. Because this wall in here will contact with that surface that I measured. So this should keep me in the same position with the fit. So we align these two, so that one will be aligned with this one. Now let's make the holes. Let's do 20 millimeters or something like that. Doesn't need much. Yeah, 18. Then we'll do like 15 millimeter threads. More than enough. And that should be it. Now we can update. Now we can add another one to the front. Now we can use this hole and this hole, J, go. And now in theory, presuming the front skirts are actually the same as the back in the original Milo. Whoa, 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 whoa. What happened there? Oh, there's, okay. There's a cutout there. So we have 280. No. We have 570. That's the one we want. So if we go to the Milo and we move this thing out, and this thing out, and if we inspect from here to here, 570. So we are in sync. Okay, let's turn off the section view here. So yeah, so that one, it's done. We can use the same fit. I want to do, like I said before, I want to do the enclosure for this machine. So I believe the feet need to be in the same position. I don't know how I haven't actually looked into the enclosure that they designed. They called it the casa. So I don't know, but I assume the feet will be somewhere specific, and this allows me to have the feet in the same position. Maybe I'll need to, I don't know if the machine bolts to the enclosure, whatever, I don't know. So if that's the case, I may need to actually drill this thing from end to end and make a counterbore here to allow me to use an M5 to bolt it to the housing, but we'll see that later. That's a problem for later. That's not for now. So again, let's continue. So now let's go to the fun part. Let's go to the where to the why we are doing all of this. So let's go for the ball screws. So I'm gonna activate this thingy, and I'm gonna put a hole in here just for reference as well. So we're gonna do a 4.2 millimeter hole here. Let's put it 10 millimeters here. Let's put it at 10 here. And let's drill it all the way because we're gonna need it on the other side as well. No target. Why? Okay, I fucked up. Yeah, okay, that's fine. Yay, do we have a hole on the other side? Okay, so now we're gonna get to the fun part. So let's go to the Milo. So here I'm gonna do my design allowing to use the hell? It's a big bird singing, and my dog doesn't like big birds. Okay, so I'm gonna, like I said, I'm gonna use ball screws, but I'm gonna leave. I intend to be able to use the manual handles as well for those who want to use it. I won't need to use it. I won't want to use it. But the idea is to design it in a way that people can use it anyway. So okay, so I'm gonna move the motor away. And we're gonna start. I'll need to, so this is the tricky part because I'm gonna need to redesign all of these now. So first let me put this thing where it was so I can see what these guys did in here. Oh, okay, so these are cutouts to, we don't need that. So we want a few things on this piece. This piece I want on here. It's only, from what I see. Oh no, actually it's bolting to both. That's good. I want this piece to do two jobs in here. I want it to bolt these two parts together. So this piece and this piece, so to strengthen the joint here, and to attach the motor and the block and whatever, everything we need in this. So we're gonna do it like beefy, kind of like this, probably even more. We'll see, because we need to. So this thing has roughly 42 millimeters. So that's what I'm gonna aim for to start with. It should have 80 millimeters from here to here. Yes, it does. And from here, let me put it where it belongs. Gonna make it easier. Okay. And from here to here, it has 65. We may make it bigger. I don't know yet. I don't mind to use another screw here on top. So maybe we're gonna make it 80-80. Okay, so we're gonna call this piece something else. So I'm gonna start with 80-80. We'll see where we go from there. That's for sure. Or, well, 80 width is for sure. And probably it's gonna be 80 height as well. We'll see. Then what we are sure as well, I'm sure I want 2 screws in here and probably 2 more in here. Let me reference them all together. And then I want some other screws or holes for screws in this side. So let's make these guys all aligned so I can select all the centers and just press the vertical. So I'm sure they're gonna be 60 from each other. Motherfuckers. Okay, let me do something else. I'm sure they're gonna be aligned like this. So I'm gonna align them 2 by 2. And now I can put here 60. I'm gonna do a reference line. So X for construction. So I can do some pointings in here. I can align these guys like that. And now I know these first ones gonna be 10 from each other, and then they're gonna be 20, 20, 20. For now, I'm not gonna reference anything because these ones, especially these ones, may need to move a little bit. Those won't. Okay, so this is the first thingy. So let's do it 42 millimeters as we said before. For now, it's a big chunk of aluminum. And let's insert it in our design. Let's call this thingy the Y motor mount. So this thing, it's gonna come on the bottom, on the back, sorry. And we're gonna mount it on the Y saddle. So Y motor mount. For now, let's leave it like this. Okay, let me put a reference on this guy. So we're gonna use I don't know if you guys are used to ball screws, but ball screws, have some blocks, they are not specific, but they are recommended blocks for the bearings, so to make the forces. They are called, the general ones, the most used ones are the BK something, where something is the diameter of the it's not the ball screw, but where the diameter of which the ball screw will need to be machined. So they are kind of specific, like if we're gonna use 12 millimeter ball screws, we're gonna use BK BF10s. So that means we're gonna need to reduce the diameter from the ball screw from 12 to 10. If we use the 16 millimeter ball screws, it's gonna be the BK BF12. If we use the 20 millimeters, it's gonna be the BK BF15s whatsoever. So basically, the number after the BK or BF is the states for the size of the block. Then there are some different blocks. There are the BK type, the EK type, and the FK type. We're gonna use the FK, which are the most compact ones. We can, let me open the browser. Where is my mouse? So Brave, let's open Brave. I know it's all black, it's still opening. Brave, I need to, yeah, should be this one. Yeah, fine. Okay, so for reference, so this is from yesterday. So let's call BK10. Okay, so this is the normal. So actually we have all of them here. Perfect. Fuck off. So this is the normal blocks for ball screws. So these are the BK type. These are the EK. Why didn't you change the picture? Motherfuckers. Okay, so these are the BK, as you can see. These are the F type, FK and FF. So these are what we are gonna use. And these are the EK. They are a little slimmer than these guys. Okay, so we're gonna use these ones. So this thing is, hey, no. So these things are appropriate. Why? So this one, it's the floating. That's why it's BF. F, it's for floating. So this one just prevents the back end of the ball screw to wobble, and it allows, you see, the bearing will slide on the hole. So it allows the ball screw to thermal expand or contract according to the variance of the temperature. And this guy here, this guy contains two, usually the good ones have two angular contact bearings. I'm not sure if you guys know what are angular contact bearings. There are different type of bearings. There are the deep groove bearings. That's the normal bearings we use every day. Then there are the thrust bearings. So the deep groove are good for radial forces. The thrust bearings, they are good for axial forces. So they don't deal well with radial, but they deal well with axial forces. Then there are more types, tapered bearings, whatever. So angular bearings, it's a mix from the thrust to the normal deep groove radial bearings. So what they have, it's easier if I show angular contact bearings images. So here we are. So as you guys can see, they are not symmetric, right? So you see you have more meat here and more meat here. That means this bearing it's appropriated to deal with axial forces on this direction, so from here to there. So the sphere, the balls, will press against that, and the inner race will press against the ball. And since you have more contact in here, you're gonna have it's gonna deal with forces, with axial forces on that direction. So if we see a deep groove, so that's a normal bearing, deep groove bearing images. So let me see a cross section. Okay, this one should be fine. See, it's just a symmetric. It's the same. It has the same meat on the back as in the front, and the inner race, it's the same thing. So this one, it's not. It deals with some axial forces, but that's not the specialty of it. It's really designed to deal with radial forces. So usually we find a set of these guys. These guys usually are in pairs. So you have one front to back. So one, basically you have two front to back, so one can deal with the forces coming from one side and the other deals with the forces from the other side. Let's see if we can find, if we put pair in here. So, hey Beanie, how are you, my friend? Here we are. So see, they can be like that or the other way around. So you can see anyway, they are opposite from each other. So one can deal with the forces from one side, the other from the other side. Sometimes they are in sets, like you have three on the spindle on the front, all the same direction, but then you have three on the back of the spindle opposite direction, doing the exact same thing. So they work three in the front and three in the back, but they all, it's always one set of bearings for each direction of forces. So that people who work with spindle, something like this. Well, actually not this. Let's see. Well, you guys are gonna have to trust me on that. Maybe if I put spindle bearings, we can see that. Okay, we are getting there. Let's see, for instance. Yeah, we can see anything in here. But in this case, usually, so this one actually have three sets of bearings. So that's not ideal for what, oh, here we are. Let's see if we can see a bigger picture of this thingy. Okay, let's open on new separator. No. Okay. This one. Okay, you see, those bearings are, those two are in the same direction. So they deal with forces from the spindle pushing back, and then in the back, they are on the other direction. You can barely see, but they are, usually these are smaller as well. The front ones are the bigger ones, and the back ones so are smaller. And these are 3, and these are only 2, because these are bigger and these are smaller. But yeah, that's the thingy. Anyway, so all this to say that the ball screws blocks, as we saw here or here, are specific with those kind of bearings, the good ones at least. Here you can actually select if you want normal ball bearings or angular, and you'll see the price goes up with the angular, because angular bearings, angular contact bearings are more expensive. So here you can actually select if you want angular or normal. Usually you want angular, because you want, if you don't need to deal with forces like a 3D printer whatsoever, you can go with normal bearings. It's fine, because it will have some force, but it's negligent. But if you're dealing with a CNC machine, you definitely want the angular contact, because these things are what will handle with the forces on the CNC machine. Otherwise, it's the motor. If these things don't handle with the forces, it's going to be the motor bearings that will handle with the forces. And the motor bearings are really not supposed to deal with those forces. I mean the motor, the stepper motors, so the movement motors. The spindle motor is different because already has those specific bearings inside of it. So they should be prepared to deal with that. Hey AR, how are you, my friend? Okay, so this is the first thing where I see the design of the Milo, the original Milo, really failing, because they use, okay, let me move to Fusion. So their design has several flaws on this area. So if we go here, okay, they actually made this full assembly. So how do they deal with the forces? First, check these collars here. I should be able to, let me see if I can isolate this assembly. Yeah, this one. Can I isolate this? I don't think so. I can only isolate a single piece. Yes, I can isolate. Okay. So first of all, they rely on these collars to actually stick to the lead screw. So that's the first problem I see. So if you leave any gap on these two pieces, you're gonna have backlash. In addition to, hi Steven. You built a Milo? Well, maybe you shouldn't watch these streams, because I think you're gonna be a little disappointed. So first, they rely on this. So I'm not sure if you guys know how ball screws are mounted. So let's get back to... Well, first let's get deeply into this. So that's the first one. So you need to actually be sure that you do any way you can to tight these two collars very snug to the bearings. That's the first thing. The second thing, let's do a cross section on this. So this is the second thing. Well, actually they changed the design. Well, let me see what I'm seeing here. Oh, did they change the design? Because should be... Yes, that's true. It would be better. I'm not even speaking about the type of the collars. I think the ones on LDO are actually the slotted, and they actually grab like a bracket, like not with the set screws going into the threads. That's not even the point. Now I'm seeing here, at least it looks like they design... What's this? Let me see. What do they call to... Oh no, it's just a 608. It's just okay. So these are deep groove bearings. So they are good for what? They are good for radial forces, not axial forces. That's right. So yes, they use a bunch of them, but yeah. It's like having a bunch of electricians doing a plumber job. Yeah, so it's exactly the same thing. At least they used a bunch of them, but yeah. So these things are really, really not good to... So they can't even deal if you tight the collars really tight against each other, so the bearings will force against each other. And they don't like that. They really don't like that. That's the first thing. The second thing, actually. What more? Then it's a printed part, but that's whatever. Hey, Antonio. And, well, that's a printed part, so we all know about the tolerances and the alignment issues and backlash and whatsoever. It's not pretty. So if they use... I understand the idea of this being a do-it-yourself, and I have nothing against using 3D printed parts, but I don't understand why didn't they design with one of those blocks instead of using 6 bearings that are not appropriate at all. Why didn't they use one of these blocks? Well, probably because they are not BF8. And they do use 8mm lead screw, but maybe it's because of that. Nothing interesting. But yeah, I really don't like... Yeah, I came across these videos, I believe. I came across these videos. So yeah, this is no bueno. And then they use the motor on the other side, which I actually don't like either. I would prefer the motor to be used on this side after all these bearings, but that's another issue. Technically, it should be the same thing. Should be fine on either way, but it is what it is. So can I unisolate this now? Let me disable the analysis, or at least this section. Okay, so my idea thank you. Hi Mike. Hey Thomas. I have no idea about the Milo, if it's 1.6 or 2.0 or whatever. I have no idea what changes are they doing. I'm working with what I know, and right now what I know it's the 1.5, and I'm dealing with 1.5 problems. So I don't know if, at least yesterday when I checked it, there wasn't no additional information about the changes they're gonna do. So far I've found quite a few problems with this machine, but yeah. Okay, so now the ball screws. Ball screws are an whole different level. So if we're gonna, let me open the here. So if we do a search for ball screw, probably most likely we're gonna find something mounted on BK blocks. Okay, we are not gonna find, but we find, well, we have it here. So here, we have the assembly of the ball screw. So you see the ball screw between the two blocks. That block is the floating, so the bearing is there just so the ball screw doesn't wobble. And the motor should be attached in here behind the BK block, and the ball screw is attached to the thingy. So how is it attached? So here we have a picture. So the ball screws are always machined in the end. So that one will accept the floating bearing, and this one is where the magic happens. So that block, it's gonna go there. It's gonna have a tight fit here, not a press fit, but a nice sliding fit, not interference, but a good sliding fit, not too loose, not too tight, but a good sliding fit. And then you'll have a nut that will preload the bearings and make sure there's no backlash between that face there and the back here. So you can actually tighten it and not rely on your capacity to adjust two colors that don't actually thread in or something. You just need to squish it as much as you can and then tie them. So here you'll have threads there, and you have that nut that will actually press the. So this is a bushing. There's another bushing on the other side, so that will compress both bearings, so there's absolutely no backlash in that system. Backlash in the nut itself, it's another problem, but I'm just talking about the ball screw and the block. And then you have all the forces, the cutting forces will be transmitted to this block, and the motor will only take care of the rotation of the ball screw. In our case, we're going to use another type of block, but it's the exact same philosophy. So it's the exact same function. It's just a different type of block. These blocks will allow you to screw on that direction or on that direction, so they can be mounted vertically or horizontally. I mean the screws holding them. Same for the floating block. But yeah, so that's what we're gonna work now. Okay, so let me change to the Fusion view. Okay, so I already I went to GrabCAD and got the F10s. Actually, I'm gonna move them, and the BK, I'm gonna move them to my where is it? Milo. Move. Yeah, I'm gonna also move these two parts because we're gonna need them. Okay, so well, we're gonna use the FK. So the FK is the one I want to use on this side. So for now, I just need some dimensions here, like this. Okay, I'll need to check this but I'm pretty sure the screw won't get to this side. So these are 17 radius, so 34. And these are... shit, that's not what I want. These are supposed to be square. 42, okay. So as you can see, I can do a cross-section of this thingy if the guy designed this thingy like it should. And he did. Well, kinda. Because he placed the bearings on the same direction, but they are not on the same direction. They are on opposite direction, but this is a design mistake. It's not anything else. But there's a few details in here. As you can see, the angular contact bearings are grounded precisely for these. So when you tie them against each other, they are ground precisely for assemblies, either back to back or back to front or front to back, whatever. So the ball screw will come here, and you'll have that nut that will tighten everything together. So yeah, okay, let's go to the what matters. So I know it's 17, so I know I'll need to mount something. But yeah, so now we have a few problems that I wasn't counting actually with Oh, okay, I want to do just I'm gonna do a rectangle 43 by 43. I know the block is 42. I know that, but I wanted to have play on it. So for now, I'm just gonna do a simple pocket here. Doesn't really matter. So this is 42 deep. Let's do it like 37, 35 for now. I just want a pocket to identify the side in here, so I don't take the risk of... Okay, actually it's fine. Just so let me unground it so I can move it, just so I attach this on the right position. J, there, boom. I can do another thing in here. So I'm gonna put so these is 34, I believe. It was 17 radius, right? Yes, it's 17 radius, so actually I'm gonna make it 34.5. Because I want it to have a little play. Let me create 2 points so I can center this thingy. For now, this doesn't really matter. I just want to be able to see to the other side. Because we're gonna need to align this, everything in here. In a minute. We can do other stuff in here since we are messing with this. Let me check the pattern of the holes. From here to here we have here to here we have really 29.7. Really? Okay, let me check the so this is a FK10 dimensions. Okay, that's what we want. I want this. Okay, so B, that's not what... Oh, okay, so this is supposed to be a circumference. Okay, so... Okay, I see. So I need to measure... Okay, so this is supposed to be mounted like that. Well, it's not supposed to be. We can mount it whatever position we want, but... I see. So that's why it doesn't have... It should have a decent, precise measurement like this. Okay, so it's 42 like that. Huh. It looks like they are FK8s, so shouldn't be a problem for them to mount an FK block on the machine. Anyway, doesn't matter. So we are looking for BCD. Yeah, okay, 42. Yeah, that's fine. Okay, so basically what they want me to do is circumference with 42. Let's call it X, or let's make it construction, sorry. And I'm gonna put a hole in here. The holes are for X. Where is X? 4.5, so they are M4. So they're going to be 3.3, 3.3, 3.3, and 3.3. So we're going to make these two guys aligned, these two guys aligned, these two guys aligned, and these two aligned. Oops, it's over constraining. Okay, guys. I'm thinking, how should I? Okay, let me make a line. I'm gonna make a line X, and let me make another line like this, X. Let me put 135 in here. Everything will settle. Oh, sorry, you guys are not. Oh, fuck. I forgot to change the. Hey, where? Okay. So I was doing the. The holes, marking the holes. Just. Okay, I want this guy. You guys want me to do it all over? I'll do it all over. Fuck that. Doesn't really matter. Okay, so we know we have the holes on a 42mm pattern, so I'm gonna do a 42mm circle. Then I'm gonna do 4 holes. It's M4, so I'm gonna do a 3.3 to open threads. So I'm gonna do another one. I forgot to add a dimension on it. I'm gonna call it this guy, D32. So D32 and D32. So I'm gonna make this guy vertical with this guy vertical, horizontal with that guy, this guy vertical with this one, and this one. Oh, okay. I can do that one because that's already those two are already done, so I can do this now. So I'm going to do a reference line in here, horizontal, and now I'm going to do a line from this one to this guy, a construction line, and I'm going to call it 45 degrees in here, and we'll settle everything up. And we have the holes for fixing the thing. And yeah, for now, that's everything we need. Now, one thing that I wasn't planning about using ball screws on this machine, it's actually the ball nut. So let's open the our functional assembly. Let me hide this guy. Okay, let's update it first. Okay, so one thing I wasn't counting is the so the width of this channel is 40mm, as you guys see here. And if we go to the ball nut, so this is a rough design of the ball nut that I already made. So this is the ball nut, the complete design of the ball nut, and this thing it's 21 radius, so it's 42 millimeters, so it doesn't fit. So it doesn't fit that there. Now I'm not sure. Let's see how much we have between the top plate. Where can I find the top plate? Here. No, actually, nope. Here and here. So in here we have 36, so that's even less. That's even less space, so there's no way the ball nut will fit in there. So like this, I think it has 30 millimeters, so that's fine. So there's no other way than modify the ball nut, and we need to cut some flats on this thingy. So it doesn't need to be precise, so we can do it with a angle grinder. If I decide to make a kit for this machine, I can provide I can do the modification myself on the ball screws. And maybe if we ask to the vendors, maybe they are willing to do that as well. I haven't asked anyone yet, so that's something. When I order the ball screws, I'm gonna be clarifying later if there's a vendor that actually can modify the ball screws. I'll tell you whatever I find. But it's nothing too serious. We just need to cut off 1.5 millimeters on each side, just to have some clearance. Doesn't need to be precise. We only need 40, but it's better to have a little more clearance. So down to 39. So it's just with an angle grinder, it should be fine. If you have a mill, with a mill, it should be okay. It needs to be a proper mill, because this thing is hardened steel. So, but yeah, an angle grinder, even a Dremel with some work can do the job. It's not a big deal, but it's something I wasn't counting. That's why I made these flats in here. So yeah. So I'm gonna close. I'm not gonna save because there's nothing to save. I don't need this. Actually, I think I'm gonna do another dummy block of because that thing it's too complex for my taste. Let me see if it even coincides this with this 10 millimeters. So I'm just looking to the yes, it's the same thing. Okay, it's the same. Okay, it's fine. Okay, moving on. So okay, now it's time to do some stuff. Okay, let's import for now. I'm gonna rename this guy and I'm gonna call it, I'm gonna leave it like that for now. I'm gonna call it Y. Okay, you guys are not seeing, but I'm just renaming the ball screw that I'm gonna put in here. Okay, so this is the ball screw. Doesn't really need to be anything too perfect. So I model it with the regular. So these are the regular dimensions for the BK block, or the EK, or the FK. That's what we're gonna use anyway. So we can actually put in also the blocks on it, to be honest. So we're gonna import the FK. So it's gonna be like this, and I'm just gonna lock it into place. So here, because this, it's gonna be mounted here anyway with this J. Okay, that's fine. Okay, let me edit the joint and let me rotate it 45 degrees. So it's just to be straight. Doesn't really matter. Okay, as you can see, it has the nut in here. And it will press in here if we do a cross section of this thingy. So inspect cross section analysis. So this nut will press everything into place. Actually, I may need to extend these threads. Maybe I misdesigned. I'm not sure. I need to confirm the dimensions from this, because there's something that's not right, and I'm not sure if it's my problem or, well, let's check. Probably it's my problem. BK10 machining images. Ten dimensions. Okay. So BK10 or or the FK10, it's the same thing. It should be the same dimensions for the. Okay, let's check here. Yep, that's the one. Okay, BK10, they say we should have L3. Okay, I need to fuck. I need to send a message. Give me a second. Okay, so should be L3 plus L, okay, L plus L1. How much is that? Okay, so L it's 25, L1 it's 30 millimeters. Okay, so the thread should be in a little less than 30 millimeters. So let me open my ball screw. So this section here, oh, okay, so I made all of these. Oh, okay. So this one is 39. Okay, as long as the threads are more than 29, yeah, it should be fine. It should be fine. No, I'm messing up somewhere. Let me see this one. Okay, L2, how much is L2? 29 and a half. 35. Yeah. Okay, I'll need to check that later, but it doesn't really matter. I can just add more threads, but I don't see the point. I don't remember where did I... Okay, let me ball screw BK10 machining. So somewhere the machining dimensions, and probably I saw the wrong place. Because usually we just ask for the ball screw. Oh, here we are. Yeah. Oh, okay. So it's the thread length. It's bigger. Okay, so I have 10 millimeters, and the thread length should be 16 millimeters. Okay, that's fine. So it should be 39, then 15 millimeters. And then the other place, it's 7 with a zone 9. Yeah, that doesn't really matter. Well, it does, but it's going to be for later. Okay, I see. Okay, so the only thing I need to do is to add more threads. So here we have 16 millimeter, and that should be fine. Let me see if I have 39 to, yes, that's 39, and should be 15 to here. That's 15, fine. Then in the end, doesn't really matter because we're gonna need to mess with this, but I can do it already. So this guy, so this guy should be 8 millimeters, not 10. Then we have a 7 millimeter extend. It is 7. And then we have a little slot of 8 minus 0.4 of 0.9. And then we have another, actually I'm gonna do like this. And it should be 2.1. So it makes 3 millimeters from here to here. And then we have a chamfer, but that doesn't really matter because we're gonna need to change these anyway. Okay, so this is the design of the ball screw. Only thing wrong was I had too little threads in there, but that's fine. Anyway, so now if we do update the design, now we should have plenty of threads to go. So the block comes with these two bushings, just to make it's basically spacers. So everything goes together fine. The nut will press everything together, then the nut itself, it has some set screws, and these set screws has some brass pieces, so when you tighten them it doesn't damage the threads. So yeah, that's cool. Okay, let's turn off the analysis again. We can add the floating side as well. Like that. And the floating side, the bearing will go there, J for joint, boom, like that. And then it's allowed, if the ball screw heats up or cools down, the bearing will slide inside of this housing with no issues. Okay, so I'm doing these already, so I can start messing with the position of the pieces. That's why I like to do these mock-ups. Okay, let's add the ball nut in here. And the ball nut, it's in the right orientation. So what I'm gonna do now, I'm gonna do a joint, a slider, position, let's call this guy, and let me go away with this one for now. That's it, that's what we want. So the ball screw slides in here. Now let's add this guy. Yeah, okay. So let me ground. I just want to move the ball nut a little bit to, well, I don't need to do that. Let me unground it. It's actually a nice, okay. If we do double press the sliding joint, we can actually move it, because we actually want to move it. Let's do it like that now, for now. Now let's put the thingy into the place. I know it's not the right position, but it's the right place for now. J. No, we want a rigid now, like that. So now we can start to see how the things look up in the picture. So for now, I'm gonna change the, can I change? Nope, I can't. Fuck. Okay, let's turn it up. Turn it off. Well, for now, we can turn off the column. For now. Okay, I see another problem that I wasn't expecting, but that's exactly why we are doing these designs. Oh, this motherfucker is tilted. That's a problem. Okay, let's fix that. Let's fix that. So it should be this. Fuck. Why is it tilted? Edit joint. No, it's not this one. It's... Which one is it? Yeah, it should be that one. Right? So this one is a rigid there. This one, edit joint. Motion. Yeah, it's a slider, it's this one. Why is the thing tilted? Which one is tilted? Oh, it's the flange one. It's not the okay. So why is my YouTube always stopping? Okay, so it's this guy. So it's this joint. Let's go back there. Okay, it's not that joint. It's this one. Yeah, it's this one. Okay. Okay, let's put this thing straight first. So this thing is aligned. What's happening, Joseph? Okay, let's join it here. Let's see what's going on with that. Let's not add any degrees to it. Nice. That's good news. That's good news. Okay, let's see. Okay, now it looks everything is straight. Let's see if everything... Fuck. What now? What now? Why is it not straight anymore? Edit joint. It was straight. Okay. How much unstraight it is? Jesus. 131.4. Okay. Is it really 131.4 or is it 131.4444? Yeah, it's 131.44. Okay. Edit joint minus 131.44. Now it's 7.1. Why? Inspect you and you. 7.12. I'm doing both. I'm decreasing pitch and increasing diameter because the original ones are not ball screws, are lead screws. They are okay. Now we're good. They are 8mm diameter and 8mm pitch, and I'm increasing the to a 12mm diameter and a 4mm pitch. So I'm doing both. Okay, so now it should be fine. What's your problem now? Oh, so I have dual. That one is straight. I assume so. Let's see. Yep, that's straight. And now everything should be kinda straight. Let's see. Let me go away with this, go away with that, and actually go away with the floating, not the floating, yeah, everything looks flat. Fine. Most likely. Not sure. Okay, so now what we need to do is start taking measurements. Okay, first let me move this thing a little to the front. Oh, fuck me. Okay, that guy. And there's another thing that I haven't considered yet, but we're gonna talk about it in a minute. I'm not sure if I can make it work, but we'll see. Okay, so now we're gonna check. So right now we have the ball nut. It's buried in the frame, which is no bueno. So let's see how much can we. Where's my face? Want this face in here. Come on, Fusion, cooperate. Are you fucking kidding me? Why aren't you selecting the face I want? Jesus, really? Oh, okay, okay, I see, okay. It was because I had okay, fine. You win this time. Okay, let's see. Yeah, because I had the joint selected. Okay, so from here to here, we have about 7, almost 8mm. Yeah, that's also why I want to get this thing going. Okay, so we can lift up the position of the ball screw up to 7.629 millimeters. So that means we can go to this thingy and go to the squarey, edit sketch, and now it's where the position of this square comes into play. So right now we have 33 point blah 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 blah. So let's go for 38. Let's save. This thing, it's pretty damn not stiff at all already. So yeah, I wouldn't consider it, I wouldn't consider to do this thingy convertible from vertical to horizontal. And first thing, I'm not a fan of those thingies, because when you adapt something to be two things, it means it won't be good and on any of those. You will have to compromise something to get another thing, always. So no, that's not even, I'm not even thinking about it. Every time someone yeah, exactly. Okay, so let's see what the modification brings us. Should be okay. So right now we are good. So we have clearance from here to the ball nut. Let me select the ball nut first. So from here to here we have 3 millimeters. We should have about the same to the floor. From here to here we have 3 millimeters, so we are dead center. So for now that's where we want to be. Now there comes another thing into play that I'm not sure if I want to get into, but it would be interesting. So ball screws have much less backlash than I'm not sure yet. The idea is to have the first I need to get the machine going. Then maybe I can always share the plans, doesn't really matter. But the idea is to, maybe if there's interest, is to make some kits available with the machine parts and whatsoever. But yeah, something on that avenue. Okay, so what I was saying, ball screws as I was saying, ball screws have way less backlash compared to lead screws. Way less, but they have some. And that some depends of the quality of the ball screw itself. I have no idea where I'm gonna buy the ball screws yet. And I'm pretty sure the machine will run pretty well with simple nut on a ball screw. My first CNC machine had these ball screws and it works just fine. My router has these ball screws, but they are a little they are on a brand, they are TBI and they are C5 rated. But they are rolled, not ground ball screws, and they have simple nuts on it, and it runs perfectly. And my VMC has ground C3 double ball nuts. So that what that means, it has two it has two nuts instead of one. And it's a grounded C3 grade ball screw. So the lower the grade, the lower the number of the grade, actually it's higher the grade. It's more precise. So in the interest of doing this machine the best possible, and since these ball screws are so cheap anyway, they cost like 30 bucks the ball screw with a nut, I'm considering getting two nuts and doing a anti-backlash system, but it's gonna be freaking hard because the space is too tight. So let's see what we can do about this. It's doable, but it's freaking hard. Just because of the space. As you can see, we don't have much space in here. If I'm gonna go up here, and I'm gonna go change the opacity to, well, actually I can change it to 0, doesn't really matter. And the same for the cars. And if I change the opacity of this little guy, shit, I can't. Can I on the body? No. Okay, I need to go to the plate itself. Yeah, here. And I can do that. I can go to opacity control and do it like 10%. And I'm gonna save it for now. And now I'm gonna plate it and it's gonna be 10% in here. There we go. Okay, maybe 10% it's too low, but let's do 20. I could break link, and actually I can do that. I can break the link and do it on the fly, because I'm not gonna change this part anyway, I think. Let's leave it for now. Okay. I can make it unselectable though, right? Unselectable. Fine. So right now I can't, yeah, that's fine. So as you can see, we have the cars there. And this is exactly why I like to have this block, simple block, everything moving, so we can actually see what hits, what doesn't hit. Okay, so basically we would need to make a system. The only way we could make this work, it would be two nuts facing each other. So the cylindrical part of the nuts would be between the cars. So basically we will need to make a block in here, tight one nut to the block the far away as possible, but we need to put screws, so it would need to be something like this. Let me check how much is from here to here. Yeah, at least, yeah, we could get away with that, 4 millimeters. And then do the other one on the other side. It's doable. It's definitely doable. Okay, let's add another nut to the mix. Because that's something I would really like to do, not because I think it's needed, but just if we are doing the best we can. So this would be the real best we can. Okay, let's do the same story. Another slide. Joint. Motion. Slider. So ideally, it would be something like this. So if I'm gonna do that, one thing I'm going to do is to actually push the motor, the mount down, or the ball screw down the most I can. So I'm gonna go 40. No, sorry. 36. So it should keep us at 1 millimeter from the floor. If I'm not mistaken. Let me move this thing away. Let me move this away. Let's select the lower face. Yeah, it's 1 millimeter from the floor. Now, we can always modify this plate, of course, but I don't see the need for now. So what do we want more? It should be offsetted, but it wasn't designed to this, so it doesn't really matter. Actually, okay, so one thing we need for sure, it's a way to attach the ball nuts to the saddle plate. So let's do that. Let's do that. Let's do a piece that should be 39. So this is Z. Let's make it 35. and this is X, doesn't really matter. I'll rotate it. So it should be 39 by, let's say for now, 15. For now. And let's make it 35 millimeters. Doesn't matter the orientation for now. So it needs to have two M5 balls, threads, I mean. Shit. I know it needs to be centered on this position. So this one divided by 2. I'm not sure about that. I know it needs to be aligned. And for now, let's make it 7.5 millimeters. So let's put it on a center for now. We'll see if we need to change these. I'm gonna make it a 10 millimeter thread for now. We'll see if we need to change this later. For now, let's work with this. We're gonna call it the what? Y nut mount. Okay, let's call it, actually, we can do 2 versions. Well, for now, okay, let's change the name for Y double nut mount. Oops, not what I want. Double nut mount. What do we want? We want this, and we want the double nut mount. Okay, so we need to completely rotate it because I fucked up the orientation. That I was expecting that. Okay, we needed something like this. And now we need to turn this guy selectable. And we need to attach it to that edge. So J, no, not sliding, rigid, like that. Okay, we need to check the distance from this hole, from what I'm seeing, should be 20 millimeters. The distance to this guy, yeah, it's 20. So let's update our drawing. So this guy in here should be 20. Finish. Save. And let's update. And now the holes should be centered. Okay, so now one thing, a few things are sure. First thing is, let me check if I haven't fucked up anything. Yeah, everything is fine. Okay, first thing we need is to drill a hole for the ball screw. So let's start with that. So I'm gonna show points. I'm gonna push the center of the, I'm gonna select the center of the ball screw and that corner. And now I'm gonna toggle the components And we need where is this coming from? So it's 15 millimeters from the bottom, and it's 19.20 from the other side. Okay, let me check from the other corner. That 0.20, it's not... Huh. Okay, something is off center here. What? I don't like that. So let's fix that first. So this is fine, 0.5 millimeters. This is fine. So the only thing I'm thinking that can be wrong, it's these freaking balls are not centered. Jesus, these guys are killing me. So if I do measure from here to here, we have, fuck you, man, fuck you, 68.7. And if we do the same thing here, to here, we have 69.3. Why? Why is this thing off center, man? Why? Why do they do this to me? Why? So they make, this way they make the plate to be actually positional. Well, actually it is, now that I'm seeing. No, it's not 5 mils off, it's like 0.7 mils off or something like that. Or 0.3 or whatever. It's actually 0.3 millimeters off, right? I think it's 0.3. But now that I'm seeing, because they have these pieces, the cars... No. It's the same thing. Yeah, it's the same thing. No, it's not. It's actually not. This one, it's a lot closer than this one. Okay, so this plate has position. Let me see if I have it in the right position. Not that we are seeing, but why? Why don't they make this symmetric? It will... Okay. Go away. Go away. Go away. Let me bring that back. Let me move this away, this away, this away. Okay, so from what I'm seeing, so that the further piece is to the back. And I believe it's exactly the other way that I have. So this is the back side. No, actually, I'm right? So the further... No, I'm wrong. Okay, let me put these on the same orientation as Milo. Milo is like that. Okay, let me activate my cars in here. So, how is it? Okay, so it looks like I'm right? So the cars in here, this is the back side. Yes, we have some gap in here, and on these ones it overlaps. Okay, at least that. So we have some gaps in here, and these ones overlap. Okay, so I'm right. So see, you see the difference? You see that thingy, and oh Jesus, my OCD would kill me if I designed this thingy. Anyway, so okay, we have to work with, if we get lemons, we need to do lemonade, right? Okay, so we have 0.8 on this side, and I think we have 0.3 on this side. No, actually you have 0.2, so we have 0. Yes, it's 0.3 difference. Because we have 0.6 difference, that means 0.3 offset. Fuck you, man. Fuck you. Okay, so that means I need to go on my double nut, and I need to go on my sketch, and I need to offset this thingy minus 0.3 or plus 0.3. Why? Fuck, it's too... Oh no, it's right. I think it's right. Yes. Okay, yes, that's right. Ah, Jesus. Okay, so now again, let's see, where do I need to put the hole? Should be on center now. So I'm gonna go with that. So we have 19.5 and 15. Okay, so let's make a hole in here. Actually, we're gonna make a bunch of holes. So we're gonna make a 13 millimeter hole, since the ball screw is 12. And it should be centered. Oh, not this way. Should be centered on this way. I'm gonna need to make it, to make some kind of mark because this not being centered makes this piece positional while it could be symmetrical. And we can make some more stuff. We can make the holes for the mounting the nut X. So let me check. Well, I can check my nut. Where is my nut? I really hate this kind of stuff because it makes no sense. I'm glad I double checked. Okay, so we have a diameter of, where is it? This guy, 32. 45, yeah, that's fine. Okay, finish sketch. So we have a diameter of 32. Let's make 4 holes, 3.3, because these are M4 millimeters. We're gonna have to thread them, I think. We're gonna make only 4. There's no need to make the 6. I don't even know if we have the space for the 6, so for now it will be fine. Okay, we need a horizontal line for reference, and we need a line to reference these guys at 45, and oh shit, oh, okay, could have done that in the same sketch of the other one, but never mind. Come on, come on. Oh, whoa, 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 whoa. Okay, I fucked up here. Yeah, fine. Okay, so we are heating these guys here so that will limit us. Okay, so this will limit our depth here to 8. Jesus, even 8. That's not too much. Well, but we have, yeah, that's not too much at all. So we have 2 options here. My music stopped again. So we have 2 options here. First, okay, maybe let me design the 6 holes. So 3.3 and 3.3. Actually, let me reference them all to the same, to this guy, in case I need to change. Okay, we have a few tweaks we can do. So let's not panic yet. There's a few stuff we can do yet before we set the house on fire. Oh yeah, I'm gonna CNC a lot of parts. Okay, for now, let's make it this way. For now, let's make it this way. So let's update it. Okay, we can offset the piece. So that's the first thing we can do. Oh yeah, yeah, we can do that. Oh, wait. We have to do that, actually. So this thingy, yeah, okay. This thingy, it's there. So if we use a single nut, it's pretty simple. It's like this. It's just like this. Nothing else. Actually, we can make it work both ways. Now that I'm looking. So I believe this is 11 millimeters, so 22. Okay, so we can do this hole instead of edit feature. No, not feature. Sorry, edit sketch. So let's do it 22.5. And this way, this part will work for a single nut. You just go there and screw in, and that's it. That's fine. And we have the problem solved. Not the problem, but we have the thingy done. Now, if we want to do the two nuts, okay, no, maybe we can't. Maybe we can't. Let me see one thing. Let me put this guy together with this guy, just a line, so I can see how much space we have between these two pieces. Okay, so we have 7.45. Let me grab an M4 button head. I think I have some in here. Yes, I do. Let me check the size of the head. So we have 2.5 millimeters. So we need at least 3.5 millimeters if we use a washer, and we need to use a washer on the ball nut, because the holes are too big for alignment. I think they are 4.8 or something like that, yes. So we need to use a washer. So we need 3.5 millimeters, so let's say 4 millimeters. Okay, so that means we need to offset 3.5 millimeters this plate. Okay, so let's make it let's make it here not centered. Now, so for 3 point, let's try plus 3.5. It's going to be off center, but let's see if it's to the right place. It's either plus or minus. Let's see. Why I get oh, actually I got lucky again. Wait. Oh, okay. I was like, what the fuck happened? Align components. Okay, so now we can always not use the top screws and use the that's always a possibility as well, not using these ones, because we can use the other four. The other four will be under the car already, so that's fine. But anyway, like this, we can use the nut on this side and probably not on this side. Well, we can, but we can't use the top screws. Okay, so I think we're gonna do two designs. I think it's best, because I really don't like stuff off center. I was just trying to use the same part for both setups, but I don't see a way to do it. I don't understand why the guy haven't done the plate symmetric. That's the first thing I don't understand, but that's so much stuff I don't understand on this machine already. Okay, so what I say is this. I say we're gonna do two parts, two different parts, because I don't like these. So this one, we're gonna forget these 3.5 millimeters. It's not, it's a simple part anyway. It's not the end of the world. We can do some chamfers here to make it prettier, but that's for later. No, that's too much. 7 maybe, something like this. And I'm gonna rename it again to no, actually, yeah. I'm gonna make a copy. Here. And we're gonna call it the single nut mount. Let's make it all caps so it doesn't feel inferior to the other. And now let's work on this one for the double nut, if we can make it work. So in order to make it work, we need to do the same thing. We need to offset it. Maybe not that much, but we need to do some offset because we need space. We need two types of space in here, and I don't even know how much space we need until, well, actually I can know. Okay, I can know that, how much space we need. Okay, so for the double, okay, let me, can I move it? No, okay, I'm gonna start closing shit. Okay, this one, for now I need it open. Well, for now I don't. This one, yeah, I'm gonna need to, this one doesn't matter. Okay, so the ball nut, definitely I don't need it. Okay, so I need some offset at least. Let's call it at least 1 millimeter. Or 2, at least 2 millimeter. I need at least 2. And this is not a problem of weakness or whatever. It should be fine. The machine doesn't have the strength to even start to distort, especially if we do this part in a good alloy, something like 7075. The machine doesn't have nearly power enough to distort this piece. Okay, so let me push the other one. Okay, so if we don't use the top screw, Jesus, it's by a little, but we can't. How much can I stretch it? How much space do I have here? 945. I believe we have 8 millimeters here. Okay, so I can push 1 more millimeter. Well, I can barely, I barely need to move it, right? Okay, so let's push it 1 more millimeter back. So we're gonna put it at +1. Yeah, +1, and it should be good for both. For both setups, I think. We'll see. Yeah, because if we put it like that, we might be, yeah, we can make it work. We can make it work for both thingies. So this one's gonna be the tight one. Let me align it for now. And now this one's going to be the second one. So in order for this to work, this is 15 millimeters, right? Right. Okay. So in order for this setup to work, we need to preload the second nut somehow. So for the in order for the double nut to work as a anti-backlash, there's no point of having two nuts if they are not pushing one against each other in order to take the backlash out, right? So this is a 4mm pitch ball screw. That means the nuts will align every 2mm because they are symmetrical. So every half turn the nuts will be aligned with each other, right? So it means we need either, since this piece is 15mm, we can make it bigger or smaller as we want. But the point is, so this is 15mm, so the second one needs to be, so this one needs to be at 1mm away from this one, or 3mm away, right? So in order to make the preload, we need some kind of spring to do the job. We don't need actually a spring. We could play just with the tightness of the screws, but that's like playing with fire, because the pitch is it's never 100% correct. It's not perfect. Never. I mean, even on C0 there will be some deviation. It's much less than these cheap ball screws that should be C7, but so let's say the pitch is never accurate. So in some sections the pitch can be 4.0002, and in other points it can be 3.9997. So we need to have something that allows play. If I can explain myself, if you guys understand me, what I'm trying to say. So the ideal is to have some kind of springs. The best springs for this, it's the Belleville washer. So it's a washer that it's not a flat, it's like a cone. It's called a Belleville washer, spring washer. Some people call it that way, but spring washer. Some people call those that are split for to act as a lock nut. In this case, it's a spring washer. It's a concave one. It's like that. DIN 2093, I believe. It's the DIN number for those. So we can do the several ways to use that spring. One way, or better said, we can use either two of those washers. When I say two, maybe three, I don't know. Well, that's the point of me spending hours speaking to the camera. It's for you guys to learn something. At least it's what I try. So we can do washers on each screw, so small washers on each screw. I have some of those downstairs if you guys want me to grab some to show, but also there's something called internet where I can show. So Belleville washer. So it's these thingies. As you can see, they are like a cone, and we can stack them. See? We can stack them. This is like series, and we can do parallels. So these are in series. We can do like 2 in the same orientation, then 2 against to double the force. We can do, I work with these things a lot for some devices. Here we can see, so this is a single, this is in parallel, this is series. You can see they are all against each other and make a big one. And this is a parallel series. That's usually what we use. So yeah, we can use 2 of these big thingies on the middle, and sorry, let me put on Fusion. So we can use 2 of those. These are not expensive. The worst. You mean for our application, Joseph, or for usually what I use them? So in our application, I would say the best case. Okay, for this, I think the best application would be 2 big ones here on the center. These, like I was saying, these things are not expensive. The problem is usually on the factory usually these are very specific. I'm not sure about Americas, but here in Portugal, I have very difficult to find them per piece. If I want a bag of 100, it's easy to buy. And it's not that expensive. It costs like 15 cents a piece or 20 cents a piece. So, but if I only need 2, why would I have to buy 100? So, but yeah. The guys in America, you guys have the McMaster and whatsoever, which is a very specialized store. I'm pretty sure you guys can buy, even if you spend like $1 on each, or even $2 on each, it's going to be cheaper than buying. If you only need like a few, it's going to be cheaper than buying a bag. But here in Portugal, it's very hard to get them by size, because like I said, by unit, because I can easily buy in Spain a bag of 100 and get on with it. So in here, I think the best way would be to use two washers in between the part, and the best thing would be we can make this piece like, I don't know. So let's say, so we have to have an even number between nuts. So we can make this piece, so we have to be close to 16 millimeters between nuts. Yes, large washers. I'll simulate what I mean in a minute. But yes, large washers around the ball screw. And we can do a case for the nuts on the actual piece, so the nuts won't move around. I think it's a good idea. We just need to figure out what size of the washers we're gonna need. And we can make this piece, instead of 15, we can make it like 15.8 millimeters, since we're gonna be close to 16 millimeters between the nuts because of the pitch, as I was saying. So the nuts gonna be aligned every 2 millimeters because of it's half the pitch and it's half the half rotation. Each half rotation of the nuts will be aligned because they are symmetrical. So we can do the part like, instead of 15, like 15.8 or 15.9 even, and then do the case at a specific depth of according to the Belleville washers we're gonna use, because they have a rate of there's a spec sheet. I can show you, it's easier. The manufacturer will provide a compression sheet. So according to the material, the steel that the washer is made, the size, the thickness, whatsoever, each it has a graphic showing like, oh, if you compress it 1.1 millimeter, 0.1 millimeters, you're doing a force, so it means you're applying a force of 100 newtons or something like that. So we can calculate to make a force of something like 300 to 400 newtons should be fine for this machine, maybe even less. So that's a 20 kilo, 30 kilo strength. Let's get right. So the more force, or the more we push the nuts, or the more force we apply, the more wear we're gonna apply to the ball screw. It's physics. So the tighter they are, the more wear we're gonna apply to the ball screw. So we don't want much, and we don't care if there is backlash during some backlash during the roughing operations. It doesn't really matter because it's a roughing operation. We're gonna get extra material to remove later on the finish pass. So the machine will make more force on the roughing operations. So it doesn't matter if the spring actually compresses or expands a little bit during those. What matters is when it's the finish operation, which is a light pass. So the machine keeps the backlash under control, and we know we won't get not even 5 kilos of force during a finish operation. So we want to keep the ball screws tight enough, but not too tight, if I'm making myself clear. So we don't need to apply a huge amount of pressure, but we want to apply some pressure. So if we go, as I was saying, if we go to the... So one store I know it sells here in our area, well, Belleville Springs. Should be fine. Disc springs, oh, so that's it. That's not spring washers, it's disc springs. That's what they call them. Okay, so this is only quotes, products. DIN 2093, that's what we want. Okay, these guys... Okay, so this is actually... should be an inventory of what they have. Can we zoom this thing? Yes, we can. I'm... Okay, so these guys don't offer a graphic, but they tell us a percentage of deflection. Okay, so let's say we're gonna need something of the inner diameter larger than 12 and something on the outside diameter smaller than, let's check. So we have the double nut here. So we need something smaller than, I would say, okay, let me put here 5.2 to give it a little room. Where is my center line? It's here. Okay. So something smaller than create driven, 26.8. Okay, so, oops, sorry. It's not what I want. We want brave. So we need something, okay, higher than 12. 12, it's too close, so 12 and a half. No, sorry. The inner diameter it's here. So let's go to the next page. 8, nope. 12, nope. 12.2, okay, that's close, but it's workable. Let's see what do we need more. So this is the thickness. Okay, this actually... it's not very... Okay, total height. Okay, so this is the thickness of the material, not the thickness of the washer. And this one is the... it's the total. So this one is the total height of the spring, of the washer. And this one is the thickness of the material. Okay, so... and this one is the cone, doesn't matter. So we have something like, so we have 12.23, which is okay, but we can do better. So 12.25, okay, that's better. It's, we need at maximum 26.8, and then we have 28. So 28, it's too much already because it will hit the screws. So we have the... this thing is. And then we have... these things are pretty strong. So let's say we have a 1 millimeter. So that's a 1.8 total. And this thing, a 1 millimeter one, shit, I really would like this thing to move with the other. So let's see, we have force in here with 15% deflection, which is almost nothing. So if we get this one was the one we were watching. So 15% deflection will get us 37 kilos. So yeah, that's pretty much nothing of deflection. So we can go much thinner material. So we can get more, we can apply more pressure. because we don't want the spring to be almost like not compressed. So if we use 0.7 millimeter thickness, we have a 1.6 total. So if we use 2, that means we have a 3.2 total length. So with 15% deflection, we have 21.9 kilos, which is cool. I would like to get less, even less, but I don't see, unless we go to the 23. Let's see the 23. 2312. 2312, we only have one. Yes, 2312, we only have one. Well, on these manufacturer, we can check on other ones. But usually these are DIN things, so everyone has the same sizes. But we can check on other ones. So here we have a 2312. So the smaller one, it's this one. Yeah, it's 296, so it's even more than this one. So I would say we would go with 2 of these. So 225. Let's model it. Okay, I'm gonna finish the sketch. Doesn't really matter for now. Okay, so how would we model this? This is gonna be fun. Okay, so they say a few things. So first thing, the inside diameter is, let's work from the center. So they say the inside diameter is 12.2. So 12.2 divided by 2, because we're gonna play in radius. So I'm gonna make a construction line here. And they say, well, I think I lost music, right? Yep. And they say the outside diameter is, well, actually I'm going to make these another way. Let's make a line like this. Shit, I made 2 by mistake. I'm going to make X, make sure it's perpendicular. So 12.2 divided by 2. And of course, I'm going to push it from here just so the line is clearly construction. And they say the outside is 25 X. So I'm going to be lazy and I'm going to put 25 divided by 2, even though it's easy math. And actually I'm going to make a line like that as well. Not sure for what, but I'm going to do it. Okay. And they say the total height is, where is it? 25 0.7, total height is 1.6. Okay, so let's make another line here, like that. X 1.6. And we know the thickness is 0.7. Okay, so doesn't really matter how we're gonna make it. Okay, let's make another line. Just why not? X. And we're gonna make it at 0.6. 0.7. Okay, so 0.7 is the thickness, so we have something like this. Actually, it's not really like this, sorry. It's gonna be something like this to be accurate. And then we need, let's do it like this, and like this. And this one and this one are like this. So this point, so this is our washer. This point is coincident with the zero shit. The zero is supposed to be horizontal and it wasn't, okay. And this point, it's coincident with this one, which is the inside radius, and that one is on the I connected this one because it's the thickness. It's connected to that one, which is the top height. So yeah, this is our washer. I'm making this line just to make an axis. So now we're gonna revolve it, and Fusion was clever enough to detect this is what I want to revolve, and this is the axis, and boom, we have our washer. So I'm not sure if this is the washer I'm gonna use. I need to check with my supplier what sizes do they have. But I'm pretty sure it's going to be something. Since these are DIN specs, I'm pretty sure it's the same sizes they have. So I'm gonna call these. I'm gonna save it. I'm gonna call it disc spring or whatever. So, according to their specifications, they say a 15% deflection is what? 25.7. So it's 290 Newton, which is about 22 kilos. And that's a 15%, and that's per washer. Since we're gonna use two, we're gonna deflect 15%, or like 7.5% of each. Because if we do 15% of the two, it's gonna be twice of the strength. It might be good. I would say 42 kilos to be a little too much. So I'm gonna aim maybe to 30 kilos, something like that. So let's call it 20%, so 10% on each. 10% on each should be a good value. So if they are 1.6, we're gonna deflect, so 10% on both, 1.6, we're gonna deflect 32 cents of a millimeter, which means if they both are 1.6, so 3.2, we're gonna deflect the 0.32. We can make like a pocket of 2.8 millimeters on the double nut. So I'm gonna use this sketch. This is just rough calculations for now because I need to check the specs of the supplier I'm gonna use. But like I said, it should be the same. So we need to, I'm gonna put 25.1 because we need some, actually it should be 0.2. Well, we'll see. I'm gonna fine-tune this value. So for now it's gonna be 25.1. And again, we're gonna, if we're gonna put our washes flat, they are 1.6 each. So this should be 3.2. But since we wanna deflect 32 cents, we should put plus 0.32. So this way we would need to push our second nut until she's like flat with the surface, with this surface here, right? Because that's the exact amount we want to deflect. So let's put an extra 0.1 millimeter. So does the washers don't. So the nut doesn't really touch the face here. I hope I'm making myself clear. With this, it's kind of complicated, but soon as I start adding the disc springs in here, I think it's going to be easier to understand. So let's do that to finalize the stream today. So see the pocket there. Now let's add the okay, so these we should add the thingy to what? Okay, this one is fine. The epsilon mount is fine. Let me see. I think I did some fuck ups already. Because the where is this thingy? No, I don't use McMaster models on Fusion because I don't have access to McMaster. So, oh, okay. So I added it on the regular. Okay, that's fine. Doesn't matter. It's better here, but okay. So the Y, the ball nut should be on here, capture position, and the mount should be on the saddle. Let's put everything where it's supposed to be. And yeah, we are practicing CAD, so why not actually practice CAD, designing the parts we need. Okay, so let's add to the saddle. Let's add the Belleville. Shit. Why? Why you do this to me? Okay, doesn't matter. Where is the disc springs? We need 2 of them. Shit. Okay. So we have them in place. They are on the components we want. Let's get back to our view. Okay, so let's press M to move. Let's orientate this properly. So I'm gonna put it like this. And this one, we're gonna put it like this. So they will face each other. So this one and this one, we're gonna put a joint. And we're gonna put a joint here with this girl, J. Boom. See? So what we have now, let's maybe do a section view. Inspect. Section view. I'm gonna choose this face. Let's cut it like that. In the middle, pretty much. Let's see, where is the middle? Kinda here, doesn't really matter. So this way, you see the spring will be cage in the block. Again, I really don't like I think this is a little too tight to the ball screw, but we'll see. I need to check whatever the springs I'm gonna use. So this way, when we go here, you see we're gonna have that, and the deflection we're gonna get. So then we can use a feeler gauge to measure our tightness. Make sure everything is pretty much the same. You can use a feeler gauge in here to make sure the nut is the same preload, or the preload we want. So we are aiming for a 0.1 gap, so we would need to put in the nut more. But again, since this is all calculated, in order to approximate the nut, we need to rotate it. And since we need to rotate it, we're gonna know if I do this tolerance here, this cage here, the right depth, it should align perfectly when I get to the right preload, right? Because they will only align at 16 millimeters. And this way, since the washers will be in the cage, we'll make sure they will never touch the ball screw. They will never move up and or down on the ball screw. And we can actually use the same piece for both both cases. We managed to do that. And I think I'm gonna actually order the double nuts then. We need to figure out the other axis, but that's fine. So right now, so if I do this, let's check if my math is right. If I do a join here, a rigid one, but if I move it, I need to move it 0.1 on this direction. I'm gonna put it here, 0.1. So we should have a gap in here. See, there's a gap. And if I go from here to here, it should be... Oh, okay. I forgot to add 1 millimeter to the to this piece. So let's do that, because that's important. So nope, it's not here, it's here. So this should be 15.9, because we don't want the 16 even, we want 15.9. Because we want the nuts to be at 16 even, which is where they are aligned. Okay, let me see if the... Shit, no, it didn't. Okay, I need to edit this joint. Minus 0.1. Let me see if we have a gap. We should have a gap. I don't see a gap though. Well, they say there's a gap. Put it like, yeah, there's a gap. And from here to this one, shit. Okay, I need to update that one. Oh, actually I haven't. Okay. I haven't grab it. Oops. Okay, I need to move. Yeah, okay. I made one mistake. Okay, if I align it. Yeah, 16 from each other. Yeah, it should be fine. Okay, let me put this thingy actually attached to this thingy. Okay, so on this one, whoa. Oh, okay, now I need to increase the offset. Okay, makes sense. I need to increase the offset in here. By 0.9 millimeters to compensate the what I increased in thickness. That's it. And we still have 5.5 millimeters there, which is plenty for our screws whatsoever, because on this one we really want to put those 4 screws in order to balance the force on the washers. You understand what I mean? It's important on this one to put the On this side, it doesn't matter because we're gonna push it flat against the mount, so it doesn't matter. But on this side, it matters because it's not gonna be touching the plate, and we need to balance the best we can the force of the spring. So it's important to put the 4 on the 4 corners. And that, my friends, it's how we put how we make anti-backlash system, let's call it, on this thingy. I'm gonna check later with my supplier, or tomorrow with my supplier, about the Belleville washers, so I can adjust the design according to the Belleville washers I'll get. So yeah. Okay, let's try to tweak in the time left. I really want to finish this at in 15 minutes, so at 1 a.m. on my time. So let's try to settle the end blocks stuff. And I need to move, these guys actually are on this, on the saddle side, not on the where they were. Okay, so let's start activating stuff so we can see what's going on with the blocks. I saw some stuff I didn't like, but it is what it is. So we need to activate these. Let's start with this end. And where is my... Y motor mount? Why is my Y motor mount not showing? Oh, because I hid it. Okay, so here we have a problem. Clearly, we have a problem. Okay, but it's not a big problem. Let me check. Where is the column? Okay, but yes, here we have another problem, right? Where is the column? Column. Yeah, okay. Let me do a cut here. Yeah, big problem here. Okay. Oh shit, that's a huge problem. Okay, this is a huge problem. Okay, so looks like we're gonna have to modify the column. It's not a big deal, but it's a deal. There's no way around it, because I can't push these further down. Well, I can, but I can't, it's not enough. How much do we have here to the floor? Yeah, we already have only 1 millimeter, so it's no good. So that's the column, my friend. That is the column. It's not a big deal, but it's a deal. Here we can get these outside, that's no problem at all. I just need to check 10 millimeters, that's fine. Where is the Y mount? Okay, here. That's fine. So 25 millimeters. Fine. That's easy. But here we need to, it needs to be done. Doesn't. Okay, we can, let's give it a little nudge more, just so I really don't like to be on the edge. Let's put it 24.5. Hey Nadir! How are you, my friend? Yeah, it's fine. It's just okay, maybe we do a little more because of the it doesn't matter. If we need to cut a piece, we need to cut a piece. It doesn't really matter. We just need to put a slot, kind of a slot on the extrusion. It's fine, but it sucks. It sucks. It sucks for the, it's not a problem for me. It's a problem for the other people. For me, it's not a problem. Thanks, mate. Thanks. Thanks for stepping by. No, 10 millimeter ball screws. There are 10 millimeter ball screws, but they are crazy expensive. It's not crazy expensive, but it's more expensive. Way more expensive. Like 3 times more expensive. Yeah, we are messing with the Milo. The main problem actually, Nuno, is the damn flanges of the nuts. They are too fucking big, to be honest. Because on the other ball screws, you get the chance of getting just this part, and not with the big ass flange that these things have, which would be perfect for our use here. But on these small ass ball screws that are not, because if we could, well, we could, but nah, we would lose the lower screws. It would be fine on this side, but on this side we already lost those, so that's no bueno. Yeah, there's no other chance. Needs to be cut. There's no other chance. No, it doesn't need to be clean or accurate. It just needs to be clearance. It's not a big deal. The worst thing is even the when we're gonna fill it with epoxy, because it's better to, well, we can fill the end with plain epoxy first, and then so it's just plastic, and then we feel like we can fill like the first centimeter with just epoxy, and then fill the rest with the thingy, but or just put a piece of silicone there. We're gonna figure it out. It's just a little bit. It's just like let's take out the stuff that we don't need to. Okay, let's take this out and this out as well. See, it's just that little bit. It looks like much, but it really isn't. But it's something. Yeah, I wasn't expecting this. And this is why, again, why I like to design everything on CAD first and test and move things around to make sure everything will fit just fine. So these guys say this thing is, oh wait, yeah, okay, from here to here, okay, yeah. So yeah, it's not much, but it is something. That's something to keep in mind. But we can do, Jesus. There are many ways, easy ways to deal with this. Worst case scenario, with a file. Best case scenario, with an angle grinder. It's fine. Even if it's filled with epoxy and sand and whatever, angle grinder and a cheap diamond disc, it will cut through it like butter. It's even, actually it should be even easier with it filled with epoxy. Just mark it 5 millimeters and done. It's probably what I'm gonna do. Okay, let's add the Y motor again. Okay, so let me do some little here. Actually, I did 43, but I'm gonna do 45. Okay, let me reference this for that one. I'm gonna do 45. And we need to do some fillets in here. Because sadly, round mills don't make square corners. So these should have to be like 4 millimeters at least. 24 and a half. Twenty-four and a half. 24, yeah, 24 and a half should be fine. A little more. It's 8 millimeter mill, so let's give it a 5 millimeter radius. Let's see if it's big enough for the BF block. Won't mess with the corners. Yeah, that's big enough. That is big enough. Oh, I'm forgetting something. So we're gonna need to drill an access hole. Well, yeah, we're gonna need to drill an access hole to screw in that little bitch. Yeah, man, I'm gonna mill everything. I'm gonna mill everything. That's the point. That's the idea. So, now that I'm looking at it, Okay, so we have another, now we have some more problems. So first of all, we need a coupler here. And I don't know the size of the, let's see what do these guys use for couplers. Okay, I really don't like these couplers. I'm probably gonna buy my own couplers. So these are what? 25 by 30, probably. Yeah, 29, 30. Yeah, 25 by 30. Okay, so let's see if we can find the couplers I like. Brave. Let's go for my most technical store, AliExpress. CNC coupler. Let's see. So no, I don't like these. I like the diaphragma ones. So the way these act, it's with that polyurethane thingy on the middle that will absorb and whatsoever. Actually, for this machine, probably they are not a bad idea. Because they are more cushioned. But what I really like, let's see if we find the ones I like. Nope, it's not these ones. It's these ones. These ones are the ones I like. Okay, but these are too long. I'm pretty sure they are way smaller, because I have them way smaller. So these are D26 and L35. So they are 26 in diameter, 35 in length. Let's see. Because I want them small. These look good. Shorter as possible. I'm pretty sure mine are smaller. I have some downstairs, I can check. I may be wrong. I may be wrong. BST automation. Really? Oh, come on, fuck off. No. Nope. BST linear? Pretty sure it's BST automation, but... why isn't it not... Okay, motor coupler. Wanna play that game with me? I'm gonna check out offline. Well, not offline, off stream. Because I ordered them. Wait, was... oh, here they are. Okay, mine are like these. Yeah, something like this. But these are... but mine weren't that expensive. So probably these are a little fancy than we need. But mine are compact like this. And I know for sure they weren't that expensive. They cost like $8 each, something like that. Okay, we are getting there. Well, last case scenario, we go with these ones, but... okay, let me see if I can find the ones I bought. Long time ago. Okay, coupler. Anti-backlasher. I put it from this store. Okay, let's see. Coupling. Flexible, I believe. Okay, not these ones. Disc coupling. Aha! Well, shit. These are expensive. Okay, 34. What's the smaller ones? So these ones. Okay, they are not that expensive. That's 21 for 3, so that's not bad at all. So we can manage. So I'm gonna order these, and these are 26. So they are 26 on both ends. And I'm gonna decide, I'm not sure yet if I'm gonna buy new motors already, because I'm really, I would really like to try some servo motors on this thingy. I'm not sure yet. So I may use the original ones, but the original ones are longer. Well, I can do spacers. We'll see. It's not that important yet. What's the maximum torque of these? Let me check. These should be... Uh, 26, right? BCD is 26. That's not much. That's not much. Well, max rated torque, it's 1.4. It's dead on these motors that come with this kit, but the motors I want to use are on the 2.2 range. Well, it's within, and that's the max torque. Well, fuck it, yeah, it should be enough. Should be fine. Yeah, 26. Okay, we can use these as reference. Oh, but that's for another day. And probably, let's see what's the price difference? That's 39, 34. So they only have 39s after the 26. Well, they have the 34, but it's not a set. Yeah. We'll see. We'll see. Okay, so guys, it's gonna be it for today. Tomorrow, we're gonna get back to it. And hopefully we're gonna move a little forward, or at least more. Well, it's gonna be the other axis. So it's gonna be pretty much, we're gonna finish this one, and we're gonna pretty much copy the stuff for the other axis. Should be very close to the same. Probably we're gonna find some more design mistakes, but that's story of our lives. Yeah, I think this size, it's gonna be perfect actually, because this thing will go here. We just need to machine this more. Well, now that I'm thinking about, maybe I can have the ball screws machined in order there's no need to change the column. It's gonna push the machine more to the back though. How much should it be? Nah, it's easier. It's easier to grind the... I'm not sure if the guys from the machining would like to... The guys that do the machining would like to do... But that would be a chance. It would be an option. If we did... If we push the... So if we push this thing like 5 more millimeters to the back, or 6, and then leave a piece here for these to hit, and then do a recess in here. No, it's not me. The guys that sell the screws do the machining according to my design. Hey, Happy MFG. Yeah, I know Fred. I know Fred for I know him for a long while actually. He sold the stuff for my first CNC machine back in 2014, so I know him for at least 10 years. Okay, so how much we would definitely... No. We would... It should be fine for this machine. We would create a weak spot, a very weak spot here. Nah, it's better to just cut the... it's better to cut the column and just get over with it. Yeah, it's better. It's best. No point. Best way is just to... Yeah, just to... machine the... just to get the... get the column a little cut out and get over with it. No point. Go away. Go away. No point on reinventing the wheel. There's no point. Okay, so yeah, that's it for today. I'm gonna take a look into the Belleville washers tomorrow and see if I need some adaptation and get the spec sheet. I'm gonna design. I'm gonna check with the. I'm probably gonna use the same style of couplers. So I'm not sure if I'm gonna go with this. It's not really important on this machine, to be honest. I really like this style, but we'll see. We will see. Because I don't know yet what motors I'm gonna use. I'm really thinking on buying a set of something like of these, like something like this. Not exactly these ones, but something on this range. Of closed loop steppers. They are not that expensive nowadays. So I need to think about it. So yeah, let's finish it for today. Otherwise I'll talk until you guys all fell asleep. So tomorrow, same time, probably I'm gonna try a little earlier tomorrow, like at usually it's at 21 p.m. my time, 9 p.m. my time. I'm gonna try something like 8:30. I'm not sure if I will be able, but I'm gonna try. But it's around same time. So we're gonna continue with this. I really want to have this done by the end of the weekend. So we're gonna continue on Friday. I'm not sure if I'm gonna be able to stream, but I'll try. We'll see. Yeah, we're gonna continue with this. It's being fun. I hope you guys are learning something and enjoying the content. So I see you guys tomorrow. Thank you for keeping up with my shit every day. And thank you for the company. Thank you for watching. If you guys like the content, please like and subscribe. It's good. And yeah, thank you very much. See you guys tomorrow. Have a good night. Take care.